regarding the sound waves, the type of sound waves, and other, that is electromagnetic and your mechanical waves. Once in tells he wants to join through school with the major portion, that is the reflection of the sound waves. And we have seen that what do we mean by saying the reflection of the sound waves. We have also observed the condition which is required for the sound to be reflected. Okay, then we have also studied about some application of the reflection of sound. Now today we will move further in the same, and we will study one of the important application of the reflection of sound. Echo. This is also based on the reflection of sound, but the reflection of sound. Now, quite often you may have observed, if you go to a monument, a large monument, okay, or you go to a place where you have got hills and other region, and you are going into a valley, and then if you speak out to hear your sound after you have produced the sound. That means after you speak out something, once you stop speaking, you will still hear the sound coming back. Okay, this phenomena is called as echo. Now, as per the definition of echo is concerned, it has been said that the sound heard after reflection from a distant obstacle after the original sound has ceased. After the original sound has ceased. So it is again a phenomena related to the reflection of the sound, but this is the sound heard after reflection. Okay, from a distant obstacle. Okay, after the original sound ceases. Ceases means stops. Okay, so it is a phenomena. First of all, it is the sound which has been heard. It's not necessary always that the reflection of the sound is audible. So echo is a condition when we are able to hear the reflected sound. Okay, another important thing is that the original sound ceases. All right, so here what we have two sounds. One is your original sound, and the other is your reflected sound. So when you are able to hear the reflected sound after the original sound ceases, we call the phenomena as echo. Okay, now this reflection of the sound can be taking place from any of the surface, reflecting surface, okay, such as cliff, hillside, walls, buildings, edges of the forest, anything else. Okay, so you are able to hear the sound. But always keep in mind the two major thing. There are two type of sounds in this. One is your original sound, and the other is your reflected sound. You are able to hear the reflected sound after the original sound ceases. So what is going to be the condition for the sound to be heard after the reflection? Because in a normal case also we have already studied that one of the major phenomena related to the sound is the reflection of sound, which takes place from any surface. Okay, maybe it is hard or soft, maybe it is polished or unpolished, smooth or rough. Okay, so at present also when you are speaking, your sound is getting reflected, but in most of the cases you are not able to hear the echo. Now, what is the condition that we are able to hear the echo, or how we are able to hear the echo? Okay, the first thing is that there is a characteristic of our human body, and especially for our ears. Okay, that is, if the two sounds are reaching to our ear, then we are able to differentiate between these two sounds only if the time gap between the two sound is of 0.1 second. That is persistence. We call it as persistence of hearing. Persistence of hearing. Just like we have persistence of sight. Okay. In reflection chapter, you might have studied that we are able to see the motion only when the uh, picture, there is a gap between the picture of less than 0.1 second. Okay. Similarly, we have the persistence of hearing, which is 0.1 second. What does this persistence of hearing mean? It means that a sound which we hear remains into our brain only for 0.1 second, which means that if a sound comes back, okay, after 0.1 second, we will be able to make out the two different sounds. Okay, this sound will be heard first, after 1 second, after 0.1 second, then this sound is going to be heard, and therefore we are able to make out the difference. So the minimum time gap which is required for the sound, for echo to take place, is 0.1 second. Now, we all know that if there is a source of sound, there is an obstacle, and if we are talking about which is at a distance d. Clear? So, if there is a source of sound, there is an obstacle or a reflecting surface. Okay, if I say it as a reflecting surface, then, and the distance between the obstacle and the reflecting surface is d, then the sound has, in case of echo, the sound has to travel from the source to the obstacle and then back, which means that the total distance which it has to travel, that is d plus d, that is 2d. So now if I apply the formula of a normal formula for calculating the velocity of the sound, so we know that the velocity of the sound can be calculated as v is equal to total distance, or speed of the sound is equal to total distance upon total time taken. Now we all know that total distance traveled is 2d, and let the time taken be t. So v will be equal to 2d by t. This is the formula which we get in case when we are observing the phenomena of echo. Okay. Now let us try to find out what is the minimum distance the echo can take place. So we are already having that velocity of sound in different medium is different. Alright, the sound travels, the speed of the sound in air will be different, in water will be different, and in solids it will be different. Okay, now we all know that. We'll consider the reference with the air. So speed of sound in air, okay, is going to be considered as, say for example, 340 40 meter per second in a normal condition. Okay, 330 is considered at 0 degrees centigrade. So at a normal temperature, we consider that at approximately 340 meter per second. Time is equal to 0.1 second. That means the time gap between the first sound and the second sound is going to be 0.1 second. So now if I have to find out t, so v is equal to 2t upon t, which means that t will be equal to v into t upon 2. This is equal to 340. I'll write down here. 340 into 0.1 upon 2, and this will be equal to 17.0 meters. So now we have the minimum distance for the echo to be produced is 17 meters. So that means if the distance between the source of the sound and obstruction is 17 meter, then you can hear the echo. All right. So I hope up till here it is clear to all of you. If you have a problem, you raise your hand. Should be such that be sufficient so that sound after reflection can reach observer. Okay, so these are the four major conditions which should be kept in mind for echo to be taking place. So I hope this much is clear to all of you.
Too low intensity.
Echo when we are talking about, yes, if it are normal, even normal, if suppose somebody is speaking very lightly, okay, very softly, so what happens, it is not audible to the backbenchers. Okay, suppose if I was in the class, my voice doesn't reach to the end, which means that my voice has not got that much of intensity. Now in case of echo, what happens, the sound has to reach to the reflecting surface and come back again. While doing this, what happened, there is a dissipation of energy taking place. Okay, sound is also a form of energy. So this energy is getting lost to the surrounding medium, and as a result, what happens, certain amount of energy is going to be lost when it reaches to the reflecting surface. After reflection, it has to come back. While coming back also, certain amount of energy is going to be lost. Certain amount of energy is going to be lost, and as a result, what will happen, echo will not be, it doesn't reach to the observer, and if it doesn't reach to the observer, what will happen, no, the observer will not be able to hear the echo. So therefore the intensity of the sound should be loud enough, or it should be large enough, which means that the loudness of the sound should be enough so that you are able to hear the echo properly. So I hope this is clear to you, Sakshi. You can mute yourself now if the things are clear. Yes, Khushi Yadav. Mute yourself, unmute yourself, ask your problem. Khushi? No problem? Okay. So you keep your... Alright. So now we move to the... Next portion. One of the application. Yes, Devesh? Unmute yourself and ask your problem.
Sir, as much the distance will be more, the echo power will be more.
it depends upon, see, it depends upon what is the distance between the reflecting surface and the energy which the sound is going to have. Okay, yes, a loud sound, whenever, say for example, if you are shouting in a, or if you are yelling in a place, okay, in a, on a hilltop, okay, you hear the echo. The reason is that there, when you, if you speak softly, you will not be able to hear that much of echo. Intensity will not be there. Clear? So that is what is the important thing. Clear? Energy is an important thing. Yes, definitely the distance between the source and the reflecting surface should not be less than 17 meters. And then we'll come to another phenomena. I'll just coming to that only, and then I will tell you depending upon. Okay?
Okay, sir.
Okay. Now, related to this only, uh, quite often now echo, when we are talking, I'm saying that okay, the sound is getting reflected. But what happens? It's not like sound is going to be reflected. Sometimes what happens, you keep on hearing your reflected sound again and again, even after you have stopped the reflected sound. Okay, such type of phenomena is called as reverberation. The phenomena is called as reverberation. Reverberation. This is basically been defined as if there is a repeated reflection at the reflecting surface, the sound gets prolonged, and this effect is called as reverberation. That means when you speak out and your sound is continuously, you are able to hear the echo. Okay, quite often when we go to monuments which has got high tomb monuments, okay, or you go to hill station, okay, so you shout from between the two cliffs if you are there, and you speak out loudly, you are able to hear your sound getting reflected again and again. Even in case of a big halls also you can hear this. Okay, it is for the same reason why the walls in case of multiplexes or cinema halls or theaters, they are got rough surface. Okay, so if there is a persistent reflection, okay, repeated reflection of the echo, it is called as reverberation. Now definitely it will be depending upon the intensity along with the distance and the other factors. Because if intensity, that is the, if the intensity is less, then the echo will die off soon, and then in that case reverberation may not be taking place, or it will be a lesser reverberation. Okay. So echo, repeated echo, you can call it as a reverberation. So I hope this is clear to all of you. Now we come to the next topic. Using the concept of echo, we can determine the velocity of sound. Very simple application we have. We have a source of, we have a source of sound, and we keep a reflecting surface. All right. Now what we have to note down, we have to note down the distance between them. So once you know the distance, this is known. Now what you do, you produce a sound, and the observer at the source of the sound, as soon as he produces the sound, he should start a stop clock. Okay, he should have a stop clock. So he starts the stop clock, and when he hears the echo, he stops the stop clock, and that is how he will be able to note down the time which has been taken by the echo. So now using the velocity, the formula 2d by t, we can find out the velocity of sound or verify the velocity of sound. Clear? So So this is a simple experiment by which you can find out echo. There are various type of this. You can say a man stands on one cliff, and there can be another man on another cliff. One fires the gun or one fires a cracker. As soon as he sees the light, he switch on, and when he hears the sound, he will be switching it off. Okay, and as a result, he can do. Okay, so various ways of finding out this. Then we have the use of echo. Why we are studying echo and what is the application of? The application of echo is very important and very much visible in day-to-day life also. Now, application of echo basically is based in terms of the sound ranging and echo depth sound. Two concepts it has been using: echo depth sounding. And a combination of this, we get it as sonar, sound ranging and sound navigation and ranging. Now, first of all, as I told you that it is basically the reflection of the sound which we are able to hear as an echo. And I also told you that the intensity of the sound should be sufficient enough to hear this. Now, as per the audible sound is concerned, we know that audible sound spreads out in all the direction. And since it is spreading out in all the directions, so definitely it loses its energy much faster as compared to some other vibrations. And therefore, for the application of echo, the most feasible vibration which is being used, that is your ultrasonic vibration. We have already studied about ultrasonic vibration, a vibration which has got a frequency greater than 20 kilohertz or 20,000 hertz. Now, what makes ultrasonic vibration more useful as compared to the audible vibration? So, ultrasonic vibrations has got certain characteristic which makes it more useful. Okay, the first is the frequency. The frequency is ranging above 20 kilohertz. All right, and because of this, this is more energetic in nature. More energetic means it will be having a greater energy, and since it will be having a greater energy, we will be able to experience the echo, the reflection of the sound in much better quality. Okay, the second characteristic which makes it more useful is it travels undeviated. Travels undeviated. Okay, through a long distance. Through long distances. Okay, audible sound, depending upon the source. Okay, some can be heard to few meters, some can be, say, somebody can speak up to say 1 meter, 2 meter, 10 meters. Okay, but it is going to die off after some time. All right, but here it can travel to few kilometers if there is no obstruction in between. All right, and with full energy, and therefore it finds its use. The third characteristics which makes it more, it is confined to a narrow beam. Now, since it is confined to a narrow beam, which means that it can travel to a longer distance, because it will be able to reduce the loss of energy, that is energy dissipation will be least or very less, and therefore it can travel to a longer distance, and even while returning back also it will be confined to a narrow beam, and it will be able to be received by the instruments very easily. And lastly, it is not easily absorbed in the medium. Not easily absorbed in the medium. With the audible sound, this is one of the demerits. It gets easily absorbed by the various medium present in between the source and the reflecting sound. So with the audible sound, what you have to do, you have to yell, you have to shout loudly, you have to speak loudly, and that also it lasts for very few minutes or seconds, few seconds only you will be able to hear. Okay, and that is not in this case. So all these characteristic of the ultrasonic vibration, all these characteristic of the ultrasonic vibration uh, makes it suitable for the use in app. Okay, so now where they are found in use. So I hope the characteristic is clear to all of you. Any doubt? Any question? Yes, Mayank. Unmute yourself.
How can be ultrasonic waves converted to narrow beam?
Ultrasonic waves are emitted in the form of a narrow beam. Alright, there are devices which confine them into a narrow beam, and that is, for example, in sonar we are using the transmitters and the receivers have been used. So these transmitters are able to confine them into a narrow beam and send them down to the seabed, and then they are able to use it to find out the various observations. Okay, and if you try to compare their wavelength also, so that way also you can make out. Yes, Kritin. Mayank, mute yourself. Kritin.
Sir, I have a question from a previous part of the chapter.
Previous part. You give me the question and I'll try to answer it.
Sir, in the same chapter, why the size of reflecting surface is more should be
larger.
The wavelength.
Larger than. See, when we are talking about a wavelength means the distance between the two region of compression or rarefaction. You understand in this way, suppose if you are throwing a ball onto a particular target, alright, now if the size of the target is small, the chances of missing it will be more. If the size of the target is large enough, the chances of hitting it will be more. Alright, so similarly here the waves have been crossing. If the size of reflecting body is less, so maximum amount of wave will be passing through the reflecting surface. Only certain amount of certain portion of the wave will be incident or will be striking the reflecting surface and will be reflected back. So major portion will be passed through. Now when we say major portion is going to pass through, which means that there will be major energy portion will be passing through, very less amount of energy will be there, so that will be responsible for reflection. So I hope this is clear, Kritin.
Yes, sir. Thank you.
Okay, okay beta, mute yourself beta. All right, so now we move to certain application of this. These have been given in your book. Like for eco, they are used by the bats and dolphins, and the fishermen are using, you all know that, bats, dolphins, and there are various nocturnal, and there are certain animals which do not see exactly with their eyes, but they are producing ultrasonic vibrations which are being produced by them, and then that has been received back by them after reflection. Okay, and thereby they are able to locate the distance between their prey or any obstruction. You might have seen bats in the evening. Okay, if you see the flight of a bat is a flying mammal. Now, if you see the any flying uh, bird or anything, they fly, they have a certain trajectory in the flight. Okay, smoothness in their flight. But bats, you will keep on finding they will be keep on changing their direction. It's only because they are emitting the sound, ultrasonic vibration, and they are receiving that, and based on that they are trying to avoid the obstruction or the prey. Okay, this method of locating an object or a prey is called as echolocation, whereby the animal emit the ultrasonic vibration and receive the reflected vibrations. Okay, and their brain and their senses are able to calculate the distances and other things. Similarly, in the process of sound ranging, the trawler man basically sent the ultrasonic vibration to find out the school of fishes. Okay, a school of fish. Then sonar you have already studied about, that is sound navigation and ranging, which has been used to find out the depth of the seabed or anything which has been drowned, or if there is any resources which are available under the seabed or the riverbed. Okay, so there they are using the ultrasonic vibration which has been sent by the transmitter to the ship and are received by the receiver, that is again been fed, and then the distance has been calculated. The same concept has been used in the radar system. Nowadays a lot of radar system has been used, especially for aviation. Okay, radar system stands for, it's an acronym. Radar is an acronym which means that it is a radio detection and ranging. RA for radio, D for detection, A for and, R for ranging, just like sonar we have. The only difference in case of a radar system is that instead of using the ultrasonic vibrations, they use the radio waves of a certain frequency and or the microwaves. Okay, again they have been used by the defense persons or the aviation for flight monitoring and other thing. So they are using this. Here also we have a transmitter which will be transmitting and then they will be receiving it. And then echo also finds its use in the field of medicine, especially the diagnostic purpose, and one of the most common application is in terms of USG, ultrasonography. Okay, if you have a problem in the stomach, or if somebody is having any problem or pregnancy or anything of that sort, always it has been used, or the doctor prescribes for the ultrasonography, that is USG, and they are able to. Now in this case also they are sending the ultrasonic vibrations which have been received and its image has been formed, and the doctor diagnosis. Okay, that is why it has been said that ultrasonic USG and other ultrasounds and other should not be very frequently been done. Okay, because that is also harmful. Ultrasonic vibrations are also harmful for the human body. Okay, so with this we finish off the first portion of the sound chapter. Okay, we have some exercises which you can do it in your copy from exercise 7a. It's question number 5. If you can write down or you can mark it in your book. State two differences between the light and the sound waves. Question number 6, what do you mean by reflection of sound? The complete question set. Question number 8, a man is standing at a distance of 12 meters from a cliff. Question number 10, explain how the sound can be determined. Okay, then we have question number 12, how do the bats avoid obstacle? Question number 15, what is sonar? State the principle on which it is based. You go through all the questions, but at least these you can write down in your copy. I'm going to explain you few numericals. All the numericals you'll have to do. Few numericals I'm explaining, and then the remaining you can do it by yourself. today time is not much left, so I will be able to explain maybe one or two examples. The first one is simple, that is based on the formula V is equal to wave lambda. The wavelength of the wave produced on the surface of the water is 20 centimeter and the wave velocity is 24 centimeter. Okay. So we have the wavelength, that is lambda is equal to 20 and wave velocity V is equal to 24 meter per second. So this can be written as 0.2 meters. Now the formula used is V is equal to F lambda. So what we have to calculate is the number of wave produced in 1 second. So number of waves produced in 1 second. This is nothing but the frequency. So F will be equal to lambda. V is equal to 24. Lambda is 0.2 and therefore this comes out to be 120, either you write down hertz or per second. The second part we have to calculate the time in which one wave is produced. Time in which one wave is produced. This is nothing but your time period. Now we all know that time period is the reciprocal of frequency, that is 1 upon 120, and you will get it as 8.3 into 10 to the power minus 3 seconds. Okay, so I hope this is clear to all of you. This is the simple one. I move to the next one, that is I'll do the fourth part. A man is standing 25 meters away from a wall, produces the sound and receives the reflected sound. That is, it is a case of echo. Calculate the time after which he receives the reflected sound if the speed of sound in air is this much, and will the man be able to hear the distinct echo, and explain your answer. Okay, so if you see the distance between the source of sound and the obstacle, that is 25 meters. That is D is equal to 25 meter. Alright. Velocity of sound in air is given as 350 meter per second. So since it is an case of echo, so we will be using the formula V is equal to 2D upon T. And what we have to calculate? We have to calculate T. So this will be 2D upon V. That is 2 into 25 divided by 350. It comes out to be 0.143 seconds. 3 means you can calculate up to 2 decimal places. Seconds. Now, B part it says, will the man able to hear a distinct echo? Yes, definitely it will be. But why? Explain. So here if you observe, the time which has been taken by this man is greater than 0.1 second, which means that is greater than the persistence of hearing. And this is the condition, one of the condition, that it should be either equal to 0.1 second or greater. And since it is greater, so he will be able to hear the sound. Okay. So I hope this is clear to all of you. If you have any problem, please raise your hand. is having any problem? 1 and 2. A person stands somewhere in between. So let the distance from the first one be d1 and distance from the second one will be d2. Now he hears the echo first for 4 seconds, so definitely it will be a closer one for, let it be t1 equal to 4 seconds and t2 will be equal to 6 seconds. Now velocity of sound is given as 320 meter per second. We will use the whatever is given as. Now to find out the distance between the cliff, the distance between the cliff will be d1 plus d2. Very clearly it is. So d1 and d2 we have to find out. So for the first case, v is equal to 2d1 upon t1. This gives us d1 will be equal to v into t1 upon 2, which means v is given as 320 into t is 4 upon 2 and we get it as 640. So d1 is equal to 640 meters. Don't forget to use the unit. Similarly, d2 will be equal to v into t2. Directly I am using the formula upon 2. V is 320 into t2 is 6 upon 2. It comes out to be 3, that is 960 meters. So this becomes your 960. So the total distance if we try to calculate, I'm rubbing this portion. So total distance if you try to calculate, that is 640 plus 960, it comes out to be your 1600. 0, 0, 15, 1, 1600. Okay. I hope this is clear to all of you. All right. And then one more I will do. Time is nearly up. Okay. So I'm not starting with the next one. It's already 10:57. So in between it will be in hurry. You try to attempt all the numericals and you will be able to do it. Okay, next class will be an important class that will be from the B section, that is natural, damp and force vibration and resonance. Okay, it's an important part. Up till this part everything is there in your syllabus. In the last part only there is some just the introduction to the characteristic of the sound and the factors affecting. Okay, examples are not there. So next class we will be joining and please keep on doing your work, learning your things. If you have a problem you can ask. 1 or 2 minutes are left. Yes, Ka. Unmute yourself. Kaf,
Sir, what is the last date for submission of second project?
Second project I will give you, beta. Most probably after this week I will send you the message. Okay. Till then you complete. You can prepare and keep it with you. Whenever it has been sent, you just submit it. Okay. And for in between, you please keep on doing your work, which has been taught. Okay. Now mute yourself, Kaf. Yes, Divyash, unmute yourself. Divyash, unmute yourself.
Yeah, I'm not having any question, sir. Actually, I'm having complaint about
Okay.
School Mitra app, sir.
Okay. Oh.
Sir, actually, we are not getting all OTP on these. Sir, I and some boys are not able
What
to
you
provide
can
the
do
meeting.
is you can send your if you want to get it registered a new number, then you please send that number, or you go to the school and tell them to update your number. Okay, because through School Mitra only we will be able to join you. Okay.
Sir, actually, I am able to, sir, but the OTP is coming so much late that the 10 minutes are
Okay, okay, okay,
past.
okay, okay. Try to join a little bit earlier, na? Okay, like
Sir,
you have to
because
join
not
today.
only I, some of the more boys are also
Ah,
facing this type of
actually,
problem.
see what we do. My son is also doing, and my both the son are doing, and I am also doing on the same. What we do is we log in and leave it. Okay, once we log it and leave it, and at the time when we have got a class, 5 minutes before, we try to connect it. Okay, so
Okay,
that
sir,
way we are able to do it. We don't log out. Yes, if the same device is to be used by the next, suppose if you have got a brother or other one, sister, then at that time you can, even both of them will be coming into the same School Mitra. Okay, beta? Alright.
yes, sir, thank you. Sir,
Okay.
because I was just only saying
Okay,
that
okay,
is there
okay,
any
beta.
solution for
Okay.
this?
Okay, mute yourself now, beta.
Yes.
Saurav, ask your problem.
Find out the project, second project, but because I've changed my WhatsApp number, so that all the
Ask from
updates
your
are
friends.
missed out.
Ask from your friends, they will send you. Okay,
Sir, can you
group
put
name
on
is
the,
better.
sir,
It
can you
is
put on
already
the,
there. It is already there in my group. Okay.
okay,
So you ask your friend, somebody will send you. Or
okay,
we'll see.
okay,
Adya,
sir.
any problem? Adya Tripathi.